I am honored and glad to have the opportunity to give a speech at this meeting. Thanks for the organizer of the International Research Award on Sensing Technology. Today, I would like to present my recent paper, Improve the Sensitivity of the Refractive Indexing with Integrated Double Layer Resonant Mental Granting Structure. I am Jinhua Hu. I come from Hebei University of Engineering. My presentation will cover the following sections: research background, structure and theory, results and discussion, and conclusions. Recently, high sensitivity, ultra-back, the integrated sensors have attracted much attention in biology test, environmental monitoring, and chemical analysis because of high sensitivity, excellent stability, real-time detection. Some optical devices has been used as sensors, such as micro-resonant, photonic suppressed, subwavelence gratings. Here the three types structures: mental granting, surface plasmonic. Micro-resonant. This is a silicon-based devices got model resonance granting. Among them, got model resonance grantings have some advantages, such as easy integration, and easy optical company, and high performance. Got model resonance grantings is like this picture. But model resonance is a valuable phenomenon in resonant granting. The three layers, the covered layer, the granting layer, waveguide layer, subsequent. The inside the incident the well, the refraction well, the transmission well, guided models are excited in the liquid model, excited in the resonance. The optical resonance is obtained when the company the between the liquid model and the resonant and the input the light wave of the reflection spectrum can be obtained by the RCWA RCWA simulation result simulation tools. We find that the resonant phenomena. Performance of the refractive the index sensors, sensitivity, Q factor, and Q factor. This is sensitivity, the calculated sensitivity. Here is in refractive index sensor using the resonant waveguide structure. We can see that the counter index of the counter layer, NC is changed, and then the central wavelength have been changed. The sensitivity is described as this. The Q factor is described this equation. However, there is a trade-off between the sensitivity and the Q factor. Is a scientific problem. In order to solve the problem, we propose a compound structure, a waveguide structure, granting layer in 2017. The structure is based on the compound resonant waveguide layer. The light wave is trapping in the granting layer, the compound using the compound structure. However, the sensitivity is limited. Subsequent because of the optical interaction between the between the leaking valve and the liquid is limited. Subsequently, we propose a static resonant compound granting structure used as a sensor. Here is the cascaded the resonant compound structure compound structure. Input the light wave and the refraction and transmission. This is a cavity. However, the cavity length is sensitive to control. It's sensitive to control. In this year, we propose uh integrated structure consists of the two granting layers with the metal grooves. One is on the top of the top, and the other at the bottom. And the slab waveguard layer in each period is a symmetric structure, which is entire covered at liquid with a refractive NC. Here is the unit cell. Here is the unit cell. We propose structures can be fabricated using nano imprint lithography. This is a theoretical model. Theoretical model. We choose a unit cell. We can see we can view the unit cell as a resonant. We can calculate the complexity angle value angle frequency using using FEM method. We view as the structure as a three-layer slab using optical waveguide theory. Then the refraction spectrum can be described as this equation. Use this equation in a theoretical model. We can calculate the theoretical spectrum. You can see that the three types of the structures. Interestingly, we find that we can see that the DG, SRG, DRMG, we can find that the sensing performance is improved with introduce of the groove structures. Here is the spectrum. We can find that the FWHM is decreasing and the sensitivity is increasing. The Q factor is increasing. The sensing performance is improved with the increase the groove structures. Here is my motivation to investigate the DRMG. In order to understand the physical mechanics, we compute the eigenvalues DRMG or using FEM. We list the eigenvalues. The eigenvalues are listed in this table. Here the eigenvalue is complexity, frequency, the real part is imaginary part, and the complex. We can see that the real part the real part is the real part value is increase, and the imaginary part is decrease. Thus, we calculated the the four structures using RCWI method and theoretical model. We combined the two results to combine the two results. We can find that they fit one very well. Very well. We can see that the decrease FWHM, the decrease FWHM, and we using the eigenvalue eigenvalue. We using the eigenvalue using eigenvalue of the resonance can predict the spectrum in theoretically. Also, we also investigated the structures with different edge. We can see that we can see that the FWHM and the sensitivity and Q factor. The sensitivity S of the sensor is increased without decrease the Q factor. We can see that the increase the Q factor increase the sensitivity. In order to understand the physical mechanics, we compute the egg model using the FEM. We can see that the light matter interactions can enhanced by the tuning the groove depths. We can see that the light trapping is shown in this figure. Light trapping is shown in the figure. By changing the distance between the up and down the groove gratings, the refractive index sensitivity can be controlled. We can see that the sensitivity and the Q factor with the different D. As a result, where theoretical simulation results the sensitivity of the sensor based on DRMG, we can find that the optimize the value of the sensitivity and the Q factor. We can see this indexing refraction index is shown in the this picture. The tuning the the central wavelengths with different refractive index of NC. Conclusions. A refractive index sensor with a sensitivity based on integrated double layer, a resonant mental granting in theoretical demonstrated. The physical mechanics of devices is investigated by the combined theoretical model and egg motion model of granting structures. The reflection spectrum of the sensor are then computed by the theoretical model and verified in RCWI method. The structural parameters of granting are tuned to achieve the purpose of the enhanced interaction between the light and the liquid, while increase the confinability of grantings of the optical field. That's all. Thank you for your attention.